Our product is called the Hokie Educator. Our team members are Shou Chen, Caitlin Gorham, and John Wei Gould. And this is a picture of our product right here. As a project management section, this right here is a Gantt chart. It shows all the tasks that we have completed, and right there shows the relationship between the tasks. This is the product planning section. This right here is our mission statement. It has a product description, benefit proposition. It just gives a general idea for our product. And then our customer needs are that the product needs to be precise, inexpensive, easy, safe, and durable. And continuing with product planning, our target specifications are shown up there. We needed to demonstrate physics, have three stations, occupy an area of 4 square feet, have a production cost below $20, and have a couple unique stations and to be user-friendly. This is the decomposition of our product. It starts with a velocity in a negative direction at a height, and it goes through station 1. It gains kinetic energy, and it's going at a negative direction in a velocity into station 2. And when it goes through station 2, the velocity is switched to a positive direction, and it's going faster into station 3, where it collides with the ball that's stationary, and then it leaves. This is the design for station 2, which is shown right over there, or station 1. These are our different concepts that we have thought of, and it shows them here why we picked the one we picked. This is our design for station 2. Shown right there. You can see the spoon and the Arduino and the battery and the motor are all included. And this table here shows why we picked the concept that we did. And station 3, it is just this part of the picture there, and it has the ball stand shown. And again, this graph shows why we picked the station that we did. And this is our complete product. There's a CAD design, and this is the picture again. This is the economics. We chose to do a varying price, which is shown right here. The varying price calculates a total revenue that is shown in the orange line on that graph. Our production cost is about $15 per unit, and we would need a present investment of $36,000 to get our company started. If we did an annual payment quarterly, the total cost, we would do a quarterly payment of about $3,500 and a yearly payment of $1,400, which equals a total payment shown here. So obviously we would pick the quarterly payment, and that is represented right there.
Hi, my name is Chen. Today I'm going to talk about the part of the architecture. So there are 4 parts that we actually want to talk about. The first part is a top ramp, which is located on the first station, and it's shown in the figure 2 for a DP3 port if you want to check it out. And so the purpose is to change the top ramp is for the upgrade mobility variety of learning skills that we want our customer to be focused on. So what we're going to try to change for this one is to input this part about helping upgrade the current system, so we can not only use a ramp, we can use something else instead to probably get more inertia to the ball by having motor shoot the ball inside the ramp instead of having a regular ramp, just having the ball slide down the ramp. So for the second part, it's a software upgrade, which is virtual for the Arduino board, which is located on the second station. So the purpose for doing that is to update and for safety, for speed control, and also focusing on the variety of learning skills. So the reason we're doing that is because Arduino is a software board, and we want to like our students to have the latest software, like including like we have the safety concerns all the time, and also most importantly is that like by having students enter different code, they can have like different rotational speed, which can make it the students actually learn more stuff. So the third one is the ping pong ball. So before our demo, we actually have made two different ping pong balls. The first one is the regular one. The second one is the one that filled with water, and we sealed the hole, which makes it like more heavier. So while like the ping pong ball glides through the first ramp, it will give us a more like inertia, so it will have more energy as well. So the purpose for doing it is to upgrade the current system to give it like a different variety of ping pong balls, so the students can actually predict by having different weight of ping pong ball, like which ramp, like which direction, and which path the ball is going to go down the ramp, and also like increase momentum as I talked about just now. And the main purpose is of course for a variety of learning skills for students. And last one is the baffle plate ramp, which is located on the third station. It's the part that's vertical, like located on the ramp. So our first design for the station 3 is to have like ping pong ball going up the ramp, and the ramp is adjustable from 0 degrees to 70 degrees, like different height. So we go from 0 to 70, and which gives a different angle, and the ping pong ball will slide through on the ramp, and it gives another ping pong ball a kick. So the problem with the third station so far is that the baffle plate right now is a little like too hard sometimes for the ping pong ball to hit it because of the like material features, because we're using cardboards. It's like really strong, so it kind of sometimes will block the ping pong ball from giving another kick to another ping pong ball. So probably in the future designs, if you want to like sell it to more people, like around Virginia, probably we want to change that just to make sure that it doesn't like take too much energy while the ping pong ball is colliding with the baffle plate ramp. So right now we're doing the slot modular architecture design.
Okay, this is industrial design, and there's 4 needs of them, which is safety, ease of use, maintenance, and resources. And here's a graph. You can see the first column is the 4 needs, and second column is importance of each of them. You can see from the graph, like for the second one, ease of use, the importance is not like high. So in our system, we just need user to put the ball in and turn on Arduino part. So this should be easy enough for them to use. So this part is not that important. And this one is assembly time worksheet. You can see that we spend total 295 minutes to make the whole system. And for the station 1, there is eight small parts for them, so we spend like 140 minutes on them. And the station 2 and 3, we just spend like around 1 hour. And okay, this is the cost sheet. According to our calculation, we spend $15 for each of our product, and we spend most of our money on the total direct cost, because if we got a very professional machine to put them together, it won't take so much time, so the labor cost is not that high.
So this is discussion for the future changes to our project right now. So the first one is a material change for less friction on the first station. So right now we're experiencing a little like too much friction while the ping pong ball is sliding through the ramp. And what I'm thinking about to change about it is to have a metallic coating that covers the ramp, which makes it like less friction. So while the ping pong ball is gliding through it, it won't take too much energy and convert it to the heat. And for the second part, we want to change the spoon motor as well. So the spoon right now is kind of just like a replacement for the current design, because we can't really find anything else, because we don't have like DIY and send it to manufacturer right now. So we're thinking about it is that because the spoon is too fragile and too weak for its material properties, we want to change it like to a metal part that's like more stronger and gives a more hard and a strong kick to the ping pong ball while it's like kicking it. And also the motor. So our current motor is like focusing on the speed. It can roll it so fast, but it can't give us like enough torque. So what happened was like while trying to like give it like injection of water to the ping pong ball, like it's gonna be really heavy, and our motor can't really carry it. So it's just gonna be stuck like probably in the middle of the ramp, like second station. So for the last part is guidance on the ramp with better material. The first part is the guidance on the ramp. So right now the ping pong ball might have like different route on the third station because it's so wide. It might go to the right, it may go to the left. So it doesn't have like a fixed route. So we want to have like guidance on the side. So make sure the ping pong ball only goes to one place. And the second part is the better material, similar with the first station changes. Then we want to have a metallic coating on the ramp so that it won't like, take up too much friction. Alright, so this is the conclusion of our entire BRG project. So for this part, for DP3 slides only, we have summarized all the 3 DPs and with like all the parts inside explained well, and also the assembly of the parts, so we can actually have the demo ready. And also we have done the economic analysis that we can decide we should sell the actually 450 demos or 400 to make the maximum profit. And also we finished the product and sent it to the manufacturer if it's possible. That we actually want them to be made and to the factory so they can be made and sold to the market. And also this is the sign, the milestone for the end of the project. And also I would like to give a great thanks to our team and also to the people who is to the lead PAPS managers that you give us the chance to have it possible. And thank you so much. And thank you for enjoying our video.